In this problem, we're asked to factor completely this polynomial here. Well, remember, the first thing you do in any factoring problem is decide, is there a greatest common factor? Well, as you can see here, not every term contains a y, and there is no numerical common factor. So let's immediately compare it to this and figure out what A, B, and C are. A is the coefficient of y squared, it's 1. B is the coefficient of y, which is 7, and C is the constant term, negative 30. So what is A times C? It's 1 times negative 30, which is negative 30. So I'm looking for two numbers that multiply to negative 30 and add to B, which is positive 7. Since the numbers I'm looking for multiply to a negative number, that means they have to have opposite signs. And if they add to a positive, the bigger one has to be the positive number. So we can start with negative 1 and positive 30, because those multiply to negative 30. And negative 1 plus 30 is 29, which is definitely not 7 that I'm looking for. Does 2 go into 30? Yes, so I have negative 2 and 15. Those multiply to negative 30, and negative 2 plus 15 is 13, getting closer. Does 3 go into negative 30? Yes, so it's going to be negative 3 times 10, which is negative 30. Negative 3 plus 10 is 7. Is that what I'm looking for? Yes. And since A in this case is 1, I don't have to write my middle term as the two terms using these two numbers. These two numbers are my actual factors. So this will factor into the binomials y minus 3 times y plus 10. So here's my answer. I factored the original polynomial, and don't forget you can always check your answer by foiling out these two binomials to see if you land up with the original problem.